Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of limits. We'll continue from question number 9. We have already worked 8 problems, and in those problems we have understood how to find the limit of polynomials, okay, rational functions as well, and we'll continue to find the limits of rational functions, and I'm going to introduce the modulus function here, all right, and here we have to rationalize, which is already used once. Well, so let's come to the 9th problem now. The value of limit x tends to 1, x raised to 1 by 4 minus x raised to 1 by 5 divided by x cube minus 1, all right. So that is of the form limit x tends to a, x to the power n minus a to the power n divided by x minus a, all right. So if you have a situation of this type, then the answer is n into a to the power n minus 1, which you know very well, correct? Now the thing is, you should have x and then a is a constant, so a is 1 here, correct? So you should have 1 raised to 1 by 4, and similarly if you are separating it and if you think that this is x to the power n, and then you should have a to the power n again, so that means you should have minus 1 here again, correct? And here this is x cube minus 1 cube, but in the denominator you must have x minus 1. I hope you understood. So we have to arrange this expression so as to suit this formula, all right. So if you want to use this formula, we should arrange things which are looking like this, okay, then only you can use the formula. So let us arrange that first. So what did I say? We need 1, okay, here as well as here, and minus 1 it is, yes. So how we are going to achieve that? Let's see. First what you need to do is you have x raised to 1 by 4 and subtract 1, and here you have got x raised to 1 by 5, add 1, okay. You can add and subtract together, then only there is no difference between the two. You cannot subtract twice, correct? If you write minus 1 and minus 1, then you should write plus 2, then only there is no difference between the two, okay. So if you are subtracting, then you should add. Now what you can do here is you can take minus common, then this will be minus within the brackets, so that will serve our purpose, right? We'll do that. Divided by x cube minus 1. Next let us take minus out of these two. So you will get minus 1 here, and if you take minus common, this will be plus, and that will be minus. Divided by you have x cube minus 1, correct? So here this is 1 raised to 1 by 4, all right. This is also 1 raised to 1 by 5, so which is 1 itself. For your understanding, you can write 1 by 4 here, otherwise leave it that way, doesn't matter. But the denominator must be x minus a, correct? What is a? 1. So you must have x minus 1 in the denominator. So what I do here is divide the numerator by x minus 1 and divide the denominator also by x minus 1. Are you allowed to do that? Yes, you can divide both numerator and denominator by the same quantity. Then there is no difference between the two. Well, now we have to arrange that again. Okay, so take the denominator here, take the denominator there, and then use the formula for this quantity, this and this, in 3 places separately. Well, so this is like a limit x tends to 1, and here you have got x raised to 1 by 4 minus 1 divided by x minus 1 and then minus. Yes, and this is x raised to 1 by 5 minus 1 divided by x minus 1 and divided by, you have x cube minus 1 divided by x minus 1. So totally 3 places. So in 3 places you have to use the formula. So which formula are you going to use? X to the power n minus a to the power n divided by x minus a if you have, and if limit x tends to a, then the answer is n into a to the power n minus 1, correct? The answer is n into a to the power n minus 1. So what is n here? X to the power n minus a to the power n. So n is 1 by 4. Okay, for your understanding you can write 1 by 4 here, 1 by 5 here and cube here. That's up to you. Okay, fine, for your understanding. Now this is we no need to write limit any longer. Okay, we are applying the formula, we are applying the limit now, we are applying the limit formula. So this is the expression we should use. So 1 by 4, a is 1 raised to 1 by 4 minus 1, n minus 1, and here n is 1 by 5. Okay, so n a to the power n minus 1 whole divided by, here n is 3, a is 1 itself, and then n minus 1 is 3 minus 1. So simplify this and that will give you one of the options as the answer. Let's do it. Okay, so simplification doesn't take much time because there is 1 raised to anything is 1 itself. You don't have to simplify this part. Okay, leave it that way. So consider only 1 by 4, 1 by 5 and 3, that's it. Okay, so 1 by 4 and minus 1 by 5 whole divided by 3. So continue with this and you will get the right answer. Okay, so what I'll do here is I'll take LCM 20. So if I take LCM 20, then this has to be 5, correct? You have to multiply 5, and here you have to multiply 4, and this is 3 by 1. I'll take it to the numerator, it will be 1 by 3. So finally 1 by 20 into 1 by 3, just multiply them, you will get 1 by 60. So 1 by 60 is the answer, and that is in the option C. Therefore option C is the answer for 9th question. Let's move to the next one. Alright, now let us move to the 10th question, which involves modulus function. Let me remind you about the modulus function first. So what is mod x? So the definition is it is minus ax if x is less than 0, and it is plus ax if x is greater than or equal to 0. Correct? So that is the definition of modulus function, and we must use it there. Alright, now if I rewrite this function, then it looks like modulus of x plus 2 is equal to minus of x plus 2 if x plus 2 is less than 0, and it is x plus 2 if x plus 2 is greater than or equal to 0. Correct? So that is like a mod x plus 2 is equal to, it is minus of x plus 2 if x is less than minus 2, and it is plus x plus 2 if x is, I'll just bring this 2 to the other side, take it to the other side, so that will be greater than or equal to minus 2. So this is the formula. This is the function we are going to use here. Now let us begin with the limit. See, the function is broken up into two branches. So if a function has two branches separately for x less than minus 2 and x greater than minus 2. Okay, so when x is, when x is less than minus 2, modulus of x plus 2 is minus of x plus 2, and if x is greater than minus 2, modulus of x plus 2 is x plus 2 itself. Okay, so that is the point where we have two different branches separated. Okay, well, so let us begin with the limit. Can we find the limit? If you are going to find the limit straight away, what are you going to get? Put minus 2 here. Minus 2 plus 2 is 0. Minus 2 plus 2 is 0. You are getting 0 by 0 form, indeterminate form. Correct? So that is direct substitution. So that doesn't work. Therefore, we have to manipulate our function and get the right answer. Okay. Now, again, if you continue with modulus and then try to replace that mod with the appropriate formula, then what are you going to replace? Are you going to replace with minus x plus 2 or plus x plus 2? So there is a confusion. Correct? We are not finding the value of the function at minus 2. We are not finding the value of the function. We are finding the limit of the function as x tends to minus 2. It is not x equal to minus 2. X is not equal to minus 2. We are not finding the value at minus 2. We are finding the limit value of the function as x approaches minus 2. It may approach minus 2 from left hand side, or it can approach from right hand side as well. So we got to find the limit separately, that is left hand limit and the right hand limit separately. Okay, so did you understand? One, we have to find LHL and RHL separately if the function has broken up into two different branches. Okay, so separately for minus 2, as we approach minus 2 from left hand side, your mod has to be replaced with this, and as you approach minus 2 from right hand side, mod of x plus 2 must be replaced with this function. So that is the difference between the other problems and the problems based on modulus. Well, so let us begin. Question number 10. See what you got. First you have to find left hand limit. So left hand limit is x tends to minus 2, yes, but from which side? Which side? Left hand side. So minus 2 and minus, and this is mod x plus 2. Okay, so that is mod x plus 2 divided by x plus 2. That is the function we have got. Well, now what are you going to substitute in place of mod x plus 2? X is less than minus 2. That is the meaning of minus 2 minus. Minus 2 minus is this side, left hand side. Okay, so when x is less than minus 2, minus of x plus 2 has to be replaced. There is no change in the denominator, there is no mod there. Okay, that is limit x tends to minus 2. Now don't put minus 2 directly, that will be 0 by 0 only again. Okay, so cancel this factor first, you are left with only minus 1, correct? So this cancels completely. Alright, now what is the limit of a constant? See, x becomes minus 2, there is no x at all. If there is no x at all, where does this apply? It does not apply anywhere, correct? So that value itself is the final answer of the limit. So minus 1 is the limit of the left hand limit. So minus 1 is left hand limit. Next, for right hand limit, you got limit x tends to minus 2 plus greater than minus 2, and that is mod x plus 2 divided by x plus 2, that is equal to limit x tends to minus 2. Now what do you replace here? Minus 2 plus. Minus 2 plus is greater than minus 2, this way. So that is x plus 2. So that you replace in place of mod divided by x plus 2. Now again don't put minus 2 directly. What do you have to substitute? What do you have to do here? Cancel these factors. Okay. So when you cancel these factors, you will get 1, and modulus limit of 1 is 1 itself. So this is equal to limit x tends to minus 2 and 1. So limit of 1 is 1. Now left hand limit is not equal to right hand limit. So in the first class I have explained when does the limit exist. Limit exists only if LHL and RHL are equal. So if they are not equal, the limit of x tends to minus 2 mod x plus 2 divided by x plus 2 does not exist. Alright, so it does not exist, therefore option D is the right choice. Well, alright. So now look at this 11th question, limit x tends to 0 mod x by x. Put 0 here, you will get 0 by 0. Therefore you must consider the formula, the function of modulus, okay, divided into 2 branches. Alright, and then we have to find left hand limit and right hand limit. Again you will get minus 1 and 1, it doesn't match, therefore it does not exist again. So please follow the previous question to get the answer of this, which is easier than that. Okay, so this I leave it to you, please do it by yourself. Alright, so please solve 11th question by yourself. Now let's move to the 12th one. Alright, look at the 12th question. As I said earlier, this is a rationalization kind of problem. You have certs here, so multiply and divide. So multiply and divide by the positive term. Okay, so if you have minus here, then you will have minus plus over here. You know that rationalization method, correct? Now what you got to do is say this is a minus b and this is a plus b. Therefore, in the denominator you will have a square minus b square kind of thing. Numerator, you hardly can do anything, so leave it that way. So a square, what is it? Square root of 1 plus x the whole square, and then a square minus b square, right? So minus, and in place of b what you have got? Root 1 minus x the whole square. Now what happens here is square root and square will cancel each other. You will be left with 1 plus x and here 1 minus x. Let's see what do we get there. No change in the numerator. In the denominator, as I said, we'll get 1 plus x and 1 minus x. Please use the bracket because you have minus sign outside. Whenever you have minus, be careful. Do it carefully. Use appropriate brackets. All right, so that you will multiply that minus again, and this will eventually become plus. Next. Now what do you do? Multiply minus. So this is 1 plus x and minus 1 and minus plus x. So here 1 and minus 1 cancels each other, and x plus x is 2x, correct? Okay, so that's the next step. Alright, the next step, what we are trying to do here is just add these two. Okay, that's the only thing we are doing in the next step. Okay, now when you apply the limit, if you apply limit at this stage, what will happen here? This will be 0 and 0 in the denominator as well. You will get 0 by 0. So don't apply the limit just now. You have to get rid of the term which is making it 0. Okay, so what is making it 0? The term x. So get rid of that and then apply the limit. Now when you apply the limit, this will be square root of 1 plus 0, and this is 1 minus 0 divided by 2. So root 1 is 1 and root 1. So that is 1 plus 1 divided by 2, which is 2 by 2. Therefore, the answer is 1 for this particular question. So 12th question has given us option B as the answer. Alright, so let's continue with the next question.
Don't forget to like our video and subscribe our YouTube channel for all the updates.